Let's solve this NEET 2020 question in current electricity. Which of the following graph represents variation of resistivity with temperature? We know resistivity is, first of all, where do you get this resistivity? Resistance of a wire is directly proportional to length, inversely proportional to area. Proportionality is eliminated with a constant called specific resistance or resistivity, where rho is a proportionality constant. It depends on nature of the material, not on physical dimensions. For different lengths and different areas, rho is same, but rho is a dependent of temperature. As the given material is copper, we can say copper is a metal. As temperature rises, resistivity also rises with the temperature for copper. So, there is only one graph which is explaining the proportionality this way. It is not going to happen this way, not in this much linearly, but a little bit non-linearly. So, that is the answer for that question. That is that first question. Let us have a look at the second question, NEET 2019. In the circuit shown below, the readings of voltmeter and ammeter are. So, first thing that we need to understand is, assuming both voltmeter and ammeter are ideal, resistance of ideal ammeter is 0. Resistance of ideal voltmeter is infinity. Voltmeter is always connected parallelly and ammeter is always connected in series. Taking that basic things into consideration, let us have a look at the circuit 1. I am talking about this circuit. 10 volts generates a current I. That current I, after coming here, is supposed to split, but this voltmeter is having infinite resistance, so that does not allow any of the current. So, ideally entire current pass through 10 ohms itself, and I can write V equal to IR. V that is passed is 10 volts, I we do not know, that is being called like, of course, I1, resistance is 10. So, I1 equal to 1 ampere, that is being shown here as 1 ampere. Let us also have a look at that V1. So, as V1 is connected across 10 ohms, voltage across 10 ohms is the reading of the voltmeter. That formula is nothing but IR. I is 1, resistance is 10. So, voltmeter V1 shows 10 volts, that is the first circuit. Let us have a look at the second circuit. This is our second circuit. In the second circuit, we do see a 10 ohms extra connected to this V2, but V2 has, being a voltmeter, infinite resistance. So, adding a 10 ohms still gives only infinite resistance. So, this lower branch together is having an infinite resistance. So, adding 10 ohms or not is not going to make any difference. So, you can redraw that circuit as 10 ohms and V2 is 10 volts. So, I am simply ignoring this 10 volts that is connected because it is connected in series with a voltmeter whose resistance is infinite. So, together this entire resistance becomes infinite. So, when a current I2 starts from here, after reaching here, no current pass through this lower branch, ideally only entire current pass through upper branch. So, this is similar to the circuit 1, is similar to circuit 1. So, that implies that I2 is I1, V2 is also V1. So, your answer is V1 is V2, I1 is I2. That is how we have to solve this question. That is a simple question. Basic understanding of ammeter and voltmeter is needed to solve this question. Thank you for answering. Thank you for being here.